Hey guys, how you doing? It's Raj over here again, back with another video from BHM at GCSE Chem, and I'm here to upload the next section of the textbook of the revision guide, which is C3.8 Fullerenes and Graphene. So the book I'm using is this one, the AQA GCSE Chemistry Revision Guide from Caboodle, and for the AQA GCSE Chemistry Revision Guide from Caboodle. And today we're doing C3.8, which is called, what's it called again? I think it's Fullerenes and Graphene. So that's a very important section. And as you would have noticed, yesterday I didn't upload a video. I'm really sorry about that. Basically, yesterday I needed a bit of a break. I thought I'd take a break especially because I think in the afternoon I had a bit of a high temperature, so I wasn't feeling 100% well enough to actually make a video, and I thought that if I'm not 100%, then the quality of the video and the teaching, the quality of the teaching wouldn't be as good as it normally is. So, well, I believe I'm a good teacher, but I don't know about you guys. Well, I get a lot of support, so that's positive. But yeah, basically I thought, because if I'm not like very well, I don't think I should make a video, because otherwise it might not help students as much. And today I'm much better, and it's calmed down now, the temperature. So I thought I'd definitely make a video today. So that's why I couldn't make a video yesterday. I'm really sorry about that. But yeah, today we're doing C3.8, which is all about fullerenes and graphene. And sorry if you can hear any background noise, but this is a very, very important section actually. And there's not much I can really teach here. It's just telling you about all the facts and stuff. So today we're doing again C3.8 fullerenes and graphene. So let's begin. And if you're following the student book, it's pages 50 to 51, and as you would have probably presumed now, hearing that I was a bit unwell yesterday, that I couldn't put the links to the sections C3.1 till C3.7 on my website. So I'll try and update it all by today, if not definitely by tomorrow. Everything should be there. So again, apologies for the delay on that regard, but regarding that, and also just before we begin as well, as you can see, I'm back in my room again to film the video, because to record the video, because basically my parents are downstairs, my family's downstairs, with my brother obviously, so I didn't want to disturb them while they're having their dinner and watching television, because I've already had my dinner. So I didn't want to disturb them then. But so now let's begin C3.8 fullerenes and graphene. And if you're following the student book, it's which is the big textbook, it's pages 50 to 51. Now, fullerenes have structures where carbon atoms join together to make large hollow shapes. So basically, fullerenes are different types of structures, giant structures, that basically where the carbon atoms, they're another form of carbon, they're made from carbon atoms again, which basically join together to make large hollow shapes. Like, you just need to remember this stuff. Like, I can't really do much here in the explanation, but what I can tell you is about that the structure of fullerenes is based on hexagonal rings of carbon atoms. So it is the Buckminster, the fullerenes are fullerenes are hexagonal. They're made. They're based on hexagonal rings of carbon atoms. However, fullerenes can also have rings of 5, which are pentagonal, or 7, which are heptagonal carbon atoms. So they can have rings of 5 carbon atoms, which are pentagonal, and then they could also have 6 carbon atoms, which are obviously hexagonal rings, and they could also have 7 rings. Rings of 7 carbon atoms, which are obviously heptagonal. And so the first fullerene to be discovered, I think I mentioned it, Buckminster fullerene. I actually was meaning in the context of what a fullerene is generally, but the first fullerene to be discovered was Buckminster fullerene, which is C60, which contains 60 carbon atoms and had a spherical shape. Yeah, so 60 carbon atoms, and it has a spherical shape. You do need to know about Buckminster fullerene. They could ask you questions about that, and that you write it as C60. 60 is subscript. You write it below the C in like small. It's a small. You write it in small. You write it in a small size, and yeah. So it has a spherical shape, and it has 60 carbon atoms basically. And fullerenes have important uses in drug delivery in the body as lubricants and as catalysts. So again, something I can't really explain it to you. You just need to remember this, that fullerenes used in they have very important uses, and these are like drug delivery, which is obviously very, very important, and drug delivery in the body specifically, and they're used in they use as catalysts as well, and they use as lubricants. So they use as lubricants and catalysts. So you just need to remember that. And the first fullerene to be discovered was Buckminster fullerene C60, which contains 60 carbon atoms. Now this is basically Buckminster fullerene here. You can see the shape, and you do not need to know the shape. Definitely, you do not need to. You do not need to know how to draw this shape. Like even I can't do that. Like it's too hard. Then they're never going to ask you that to draw any kind of fullerene shape, because it's very, very complex, and especially Buckminster fullerene, they're not going to ask you to draw these things basically. But I think just going back for a second, I think they would ask you. They could. I mean, it doesn't come up a lot. But I have seen questions like it where they could ask you to draw diamond, structure of diamond, or even structure of graphite. So these are the two I would definitely learn, which is obviously in C3.7 giant coordinate structures. So in the last section, but the ones in this section, you don't need to know how to draw fullerene. Like they can't ask you that. Like that's just too much. And now here's a question, which element do all fullerenes contain? Well, remember, they have, carbon atoms, so the answer is just carbon. So the answer should be carbon atoms. Which elements? So just say carbon. So you don't need to say carbon atoms, just say carbon. And that should be the answer, which I will just check now. Just make sure. Yep, carbon. Yep. And then cylindrical fullerenes, now we're looking at cylindrical fullerenes, are called carbon nanotubes, and these could also be produced. The nanotubes are very thin cylinders with very high length to diameter ratio. So this isn't very important, you just need to know what cylindrical fullerenes are basically called. They're called carbon nanotubes. These can also be produced, and you could just remember that these carbon nanotubes have they're thin cylinders with a very large with a very high length to diameter ratio, but these are very, very small things that you may as well remember them, because why not? It's just remember that carbon nanotubes, they're very thin, they're very cylindrical fullerenes are carbon nanotubes, and they have they're very thin cylinders which have high length to diameter ratio. Like I don't even it doesn't even come up in A-level chemistry. It's not very important, but just remember it. Carbon nanotubes are very useful. Carbon nanotubes have very useful properties. Now these are important. They have a high tensile strength that makes them useful to reinforce composite materials for making tennis rackets. So just remember that exact wording. I mean, this is just rote learning. Literally, is that what it's called? Just you need to regurgitate all this. It's not even that. It's not very logical. That's why I don't really like this section much, because it's not very logical. Sorry about that noise, but you just need to remember all this really, and I think the properties you can definitely be asked on, so this is very important to remember. The carbon nanotubes, they have very useful properties, like for example high tensile strength, and these can be used basically to reinforce composite materials to make for making tennis rackets. So it's used for the materials that are used to reinforce those materials, composite materials that are used to make tennis rackets. And they have delocalized electrons, giving high electrical conductivity. They obviously also, because they have a high electrical conductivity, they can then be used in the electronics industry. So remember, carbon nanotubes, they have very useful properties. They have a high tensile strength, and these can be used to reinforce composite materials to make tennis rackets. And they also have delocalized electrons, and therefore this makes them, be able to conduct electricity. They're high, they have high electrical conductivity, and therefore they can be used in the electronics industry. So I don't think that's bad. That is that bad. I think you can remember it. Like, it's pretty logical. If you have delocalized electrons, it can conduct electricity, stuff like that, and it can be used, to reinforce composite materials for making tennis rackets. What are fullerenes used for? Well, they're used for drug delivery in the body, and they're used as lubricants and catalysts. So some of these uses you just need to know, really. I'd recommend knowing all of them, just to be safe, Graphene. Okay, now we're going on to graphene. Now, graphene is different from graphite. It sounds like graphite. It's not. It sounds somewhat similar to graphite, but it's not. So graphene is a single layer of graphite. It's similar to it, but it's a single layer. It's a layer of hexagonal rings. So remember, graphite we just go through as well. Graphite is also, hexagonal rings. They form hexagonal rings, and also graphene is a single layer of graphite with a layer of hexagonal rings. And the thing about graphene is that it's one carbon atom thick. So that means it's very, very thin. Like, one carbon atom thick means it's really, really thin. Like, it's not thick at all. Like, that's what one carbon atom thick means. It means it's very, very thin. And I believe it's the thinnest material in science, actually. Don't quote me on that, but I did read it somewhere. I did read that somewhere. I think that graphene is the thinnest material in science. But don't quote me on that. Don't say that in your exam either. Just say graphene is a single layer of graphite, and it's only one carbon atom thick. And they might ask you, what does one carbon atom thick mean? Well, that it just means that it's very, very thin. Graphene is a very, very thin material. Graphene is an excellent conductor of electricity. It has a low density, very low density, and it's incredibly strong for its mass. Yep, it's incredibly strong for its mass. Therefore, makes it useful in electronics and composites. So again, graphene can be used in electronics and composites, basically. Just remember that as well. And it, like graphite, it can conduct electricity. Yep. And yeah, it has a very low density, just things you have to remember, really. I can't really do much with this, and it's really strong for its mass. So yeah, I don't know how much this video is actually helpful with me just reading the textbook out, but literally I cannot do anything much more than reading it out, because literally this part, whenever I used to do this section, I was like, oh my god, just things you have to remember. Like, I'm really sorry, there are things in chemistry that you have to remember, and that don't really seem very logical sometimes. You just have to get it in your head, and this section is one of the this is one of the examples of that, basically. And here's a question 2, and the last question of the section is, give one similarity and one difference between graphite and graphene. So graphite. So the question is, give one similarity and one difference between graphite and graphene. So the similarity, you could say, is that they both have hexagonal rings. We know that graphite and graphene are both materials that you learn about in chemistry, and they both have they have hexagonal rings. And you could also say they are made from carbon atoms. I'm pretty sure it is. Yeah, one carbon atom thick. You could say they're made of carbon atoms as well. So they should be like 2, just so that in your head. We're going to see the answers as well, but I've given 2 there. One difference between graphite and graphene. And also, you could also say one similarity is that they both conduct electricity. That's another thing. And a difference between graphite and graphene, again, what can we say here? Graphite is, graphene is only one carbon atom thick, basically, and it is much thinner than graphene. Graphene is much thinner than graphite, only one carbon atom thick. I think that's really the only difference, really, isn't it? I'm pretty sure they didn't really, explain the difference between graphite and graphene that much in this textbook. But yeah, we'll see the answers just to make sure. I'll just see the answers just to make sure if there's anything else, because to be honest, this was a section that I struggled with myself. But yeah, so similarities, forms of carbon. I said that they have covalent bonding. That's true. We could have said that. and hexagonal rings. I said that as well. So I said 2 actually out of the 3, and you only needed 1. But yeah, the thing I didn't say was obviously. So let me just repeat the similarities again. They're forms of carbon, which I said they're both made of carbon. The covalent bonding is what I didn't say, but they do have covalent bonding. Both graphite and graphene have covalent bonding, and they both have hexagonal rings, which I also mentioned. And the differences are that graphite has layers. Yep, graphene layer only 1 atom thick. So I did mention that graphene layer is only, graphene is only 1 atom thick. It's better to say graphene layer is only 1 atom thick, and you could also say, you should say graphite has layers, because it does have layers, remember. And in between the layers, we went through this in the last video actually, that between the layers there are weak intermolecular forces between the layers for graphite, and graphene has layers which are only 1 atom thick. Again, sorry if you can hear any noise from sorry if you can hear any noise from the background, but yeah. And the keyword, wait, why am I'm on fullerenes. So yeah, the keyword of the section is basically fullerenes, but I think graphene is also a very keyword, very important to know about graphene, and the difference between graphite, similarities and differences between graphite and graphene are very important. And yeah. And here's just here's just what is it? Am I showing it properly? Wait, am I showing the wrong thing? 1 minute, sorry about that. Yeah, here. So you can see hopefully in this image. This is just an image of graphene, a computer generated image of graphene. Then this blue one there. This blue diagram, but not diagram, but blue thing. So yeah, a computer generated image of structure of graphene. Yeah. So again, really sorry if you can hear any noise. Key points just to finish off, that are, as well as diamond and graphite, carbon also exists in fullerenes. These can form large cage-like structures based on hexagonal rings of carbon atoms. So diamond and graphite, carbon also exists in fullerenes. So fullerenes are also made of carbon atoms. They can form large cage structures and based on hexagonal rings. So again, fullerenes are made of hexagonal rings, but remember these rings could also be pentagonal or heptagonal. We've been through that as well. The fullerenes are finding uses in transporting drugs to specific sites in the body. We've been through that, drug delivery in the body. We've actually been through that, basically transporting drugs to specific sites in the body, and also as catalysts and as reinforcements for composite materials. We've been through all this before. Just a recap of what we went through. Just need to remember this. Really, I can't really do much here in terms of explanation, so sorry about that, guys. But yeah, and the last point before we finish off this section is that graphene is a single layer of graphite, and so isn't just one and so is just 1 atom thick. So graphite is graphite has layers, and graphene has layers which are graphene layers are 1 atom thick, 1 carbon atom thick, so very, very thin actually. Yeah, its properties are such that it can its excellent electrical conductivity will help. Yeah, its properties such as its excellent electrical conductivity will help create new developments in the electronics industry in the future. So you can say, these can be used in electronics in the future as well. And one similarity that they didn't mention, obviously, which I mentioned before and now as well, that graphene and graphite both conduct electricity. So when they ask the question between give one similarity and one difference between graphite and graphene, you could also have mentioned, it doesn't say in the book, the mark scheme, in the answers, but definitely that is another similarity. Both graphite and graphene can conduct electricity. They have they have high electrical conductivities. So yeah, that's the end of the section, guys. Again, really sorry I couldn't make the video yesterday. Didn't feel 100% well to actually make the video, and I felt that if I don't feel 100%, there's no point making the video. Needed to take a break because of obviously the high temperature, but now it's gone down, thankfully. But yeah. Tomorrow I'm going to be going through C3.9, which is bonding in metals. I believe it's bonding in metals, yeah. And again, sorry I haven't been able to see. So C3.9 is bonding in metals, and I haven't been able to put the links up to after 3.1 C3.1. I haven't been able to update it on the website yet. Put the links on the website yet, which I will do soon. Hopefully by today I'll put the links on the website, or definitely by tomorrow. But yeah, hopefully it was useful. Make sure to share, like and subscribe, and turn the notifications on if you haven't already, so that you're notified and updated when you can, when I make new videos that you can watch. And until tomorrow, see you guys. Thank you very much.